Okay, the next thing we look at is finding the x and y intercepts, and we need to start by remembering standard form of a linear equation, and that would be ax plus by is equal to c. With this, when we're talking about x and y intercepts, an x-intercept is going to fall on the x-axis, meaning that it's going to have a value for x, but y value would automatically be 0. Y-intercept is going to be very similar, except for this time it's the x value that is automatically 0, and our y value is what we're going to try to find. So when we go to calculate this, we're going to take the equation, and when we're looking for an x-intercept, we automatically will plug in a 0 for its y value. So you can see here I have 2x plus 5 times 0 is equal to 10. Now from there, if I multiply 5 and 0 together, that's just going to cancel. It's just going to be 0. So really I can change this to just being 2x is equal to 10. And we solve from there. So divide both sides by 2, and we should get x is equal to 5. Then for the y-intercept, we're going to do the opposite. We're going to take that same equation, but this time we change our x value to a 0. And we're going to solve for y. So just like what we saw happen with the x-intercept, again, right here, 2 times 0, that's just going to cancel. So really, we're just left with 5y equals 10. We'll divide both sides by 5, and we end up getting y is equal to 2. So now we'll do the same thing with examples 2 and 3. First of all, I'm going to divide these up a little bit to just give myself some organized space. That way I can solve the x-intercept on one side and the y-intercept on another side. Again, for the x-intercept, we want to remember which one is going to become a 0. We're trying to get rid of the y value here. So the y value is what is going to turn into a 0. So now I've got 3x minus 0, which means that y is just going to be gone. I really just get 3x is equal to 5. We divide by 3, and we're going to end up getting x is equal to 5/3. Now, in this case, I would want you to leave it as a fraction. We don't want to change that to a decimal because it would be a repeating decimal, and when we round that, we would not have the exact intercept. So please make sure you're leaving it as reduced fractions. We move on to the y-intercept. Take that same problem. This time it's the x value that's going to become a 0, meaning that 3 times 0 is just going to wipe out. So you can see I'm crossing that out, and I'm now just left with negative y is equal to 5. Here I have to get rid of that negative, so I'm going to divide both sides by -1, and I end up getting y is equal to -5. So we have our x and y intercepts in number 2. In number 3, we'll do the same thing. Here I'm going to plug in a 0 for y, which means that the 3y is going to be gone. So I'm really just left with 7x is equal to 21. We'll divide both sides by 7. I end up getting x is equal to 3. From there, I'll do the same thing, but for the y-intercept, we're now going to make the x value a 0, meaning that that part's going to wipe out. We're left with 3y is equal to 21. I'll divide both sides by 3, and we're left with y is equal to 7. In this slide, we're going to find the slope. Now, to find the slope in these, the best way to do it is to put everything back into slope-intercept form and identify it from there. So in example number 1, what we'll do is subtract a 2x on each side. Now we're going to be left with 5y is equal to, these don't combine, 10 minus 2x, they are not like terms, so I have to leave it as negative 2x plus 10. Technically, those can be in either order, but really we should put the x value first. Next, we divide both sides by 5, and we're left with y is equal to negative 2/5 x plus 2. Now, once it's in slope-intercept form, it's pretty easy to identify what the slope is. That's going to be the value that ends up in front of the x. So we get a slope here of negative 2/5. We'll do the same thing for number 2. I'll start by subtracting 3x on both sides. I'm left with negative y is equal to negative 3x plus 5. We'll divide both sides by -1. We're then left with y is equal to 3x minus 5. Slope here, again, in front of the x value is going to be 3, and that's our slope. And then finally for number 3, if I subtract 7x on each side, I end up getting 3y is equal to negative 7x plus 21. I need to get rid of the 3 here, so we're going to divide everything through by 3, leaving us with y equals negative 7/3 x plus 7. Again, whatever is in front of x is going to be our slope, and that is negative 7/3. Okay, and this last part is going to be to determine if a point represents a solution. And so what we need to do here is remember that when we're given a point, it represents an x value and a y value. So we're going to take the x value and plug it in for x, and we're going to take the y value and plug it in for y. And it would look like this in example 1. Now, from here, we're going to do some calculation. If I multiply 2 and 2 together, I'm going to get 4. If I multiply 5 times 1/4, I'm going to leave that as 5/4. Now, hopefully we can kind of see right now, if I were to do 4 plus 5/4, keep in mind that 5/4 is the same thing as 1 and 1/4. I would get 5 and 1/4 or 5.25. So in my mind, without really doing anything further, I kind of know that this is not going to give me a true statement. But if we want to actually put these together, we want to get common denominators here. And so to get common denominators, I'm going to need to change this one, which is currently 4/1, and make that have a denominator of 4. So if I want that to have a denominator of 4, I have to multiply top and bottom by 4, which gives me 16/4 plus 5/4. And then that final step would be to add the 16 and 5 together, giving me 21/4 is equal to 10, and that's just not going to be true. Now, if it gives us a false statement, that it means that it is not going to represent a point on that line. If we were to graph this, that point would not fall on the graph of this line. Okay, and now we look at number 2, doing the same thing, plugging in 1 for x and 2 for y. We've got 3 times 1 minus 2 is equal to 5. I would encourage you to get in the habit of putting everything in parentheses when you're plugging things in, just because sometimes we can make mistakes with negatives. So from here, 3 times 1 would be 3, minus 2 is what I end up with, equals 5. That is not going to be a true statement because we know 3 minus 2 is going to give us 1. 1 is not equal to 5. So since it's false, again, no, this point does not fall on that line. For our final one, again, we're going to plug in these values here. So I end up with 7 times 24/7 plus 3 times -1 for y is equal to 21. Now, don't be intimidated by this step right here. When we're multiplying 7 times 24/7, what ends up happening here is that this 7 is considered the numerator, and this is the denominator. So they're going to cancel. That means I'm just left with 24. 3 times -1 is going to be minus 3 is equal to 21. And that is a true statement because here I would get 21 is equal to 21. Since that is true, that point is going to fall on the line. If I graphed this and plotted that point, it would fall on that line. So finally here, what you want to do is complete the following assignments in Delta Math. There are 3 topics and they are loaded into the system for you already.